Hey everybody. So right now we're missing the smartboard. So for now we're going to do the lessons through here. We'll just make it work. We're going to finish up our last unit of the year and it's all about circles. You'll be getting a new packet in class. Make sure that you are following along and getting the notes down just like you would in class. So today we're going to talk about 11-1, which is lines that intersect circles. So some terms you're going to see: a chord. A chord is a segment whose endpoints lie on a circle, okay? Doesn't have to go through the center. A secant is a line, that intersects your circle in two places. So a secant intersects a circle in two places. And a tangent is a line that intersects it at one point, okay? And one thing to know about a tangent, if you were to draw a radius to that tangent, it's always going to be 90 degrees, right? They're going to be perpendicular. The point of tangency is the point where your tangent line hits your circle. All right, so let's identify these things. You could actually consider a couple of these chords. So EF, if we're just talking about a segment, okay, not a line. And the other one would be your diameter that you see here, BC. And remember, when you're writing a segment, you just put a dash above it. Your tangent line would be line L. See how it's in cursive there, lowercase? Your secant would be line EF. Now, it doesn't have a cursive letter there, so for EF, when we write that, remember you put the dash with arrows because it is a line. It's going to continue. Radii is plural for radius. So from A to C, again, that's just a segment, and from A to B. And your diameter would be all the way across BC. Okay, so some also point of tangency on this particular one. Where does the tangent line hit? That would be point C. All right, so some examples to look at when you're dealing with a tangent line, or two tangent lines, excuse me. If they're both drawn to your circle, they are congruent to each other. So we're just going to set up an equation. 5y minus 28 equals 3y, and you could go either way with it. I know a lot of you like to bring the smaller one over, so I'll show you that way. So we'd subtract the 3y. Remember, draw the line down if you need to. You're left with 0. Over here you have 2y minus 28 equals 0. 0 is a number, that's fine. Add 28 to both sides. So 2y equals 28. Divide by 2. Whoops. Y is equal to 14. It wants us to determine DE. So from D to E, we're going to do 5 times 14 minus 28. My calculator's not working on here either, so I'm just going to do it in my calculator. 5 times 14 minus 28 is 42. So DE equals 42. All right, same thing on the next one. If you want, you can pause the video and give it a try, but they're equal. Don't be afraid of a fraction. X over 4 equals x minus 6.3. Well, the only thing over here is that if you want to get rid of this fraction right away, you can cross multiply. So 1 times x is 1x, and then we'll do 4 times x minus 6.3. Don't forget to distribute. So 4 times x is 4x. 4 times 6.3 would give us minus 25.2. Now, we want to get the x's together. I'm going to go the other way with it. 1x is already by itself, so I can subtract the 4x, which is probably the way I would have done it over here as well. But I'll show you both ways. You're left with negative 3x equals a negative 25.2. And then you just have to divide by negative 3. Negative divided by negative is positive 8.4. So there's your x value. We'll want you to find RS. RS is x divided by 4, so 8.4 divided by 4, RS is going to be equal to 2.1. Okay, so again, when you have two tangent lines drawn from the same point, those values are equal. A couple others we're going to look at today. Inside the circle, if you have two chords that intersect in the interior of a circle, the product of the lengths of the segments of the chords are equal. So what that means is AE times EB, so this part times this part, is congruent to CE, this part times this part. So let's look at a couple examples. So with this, we have SQ is X and QT is 8. So I can do 8 times X equals, and then it's equal to PQ times RQ, 6 times 4. So again, it's part times part equals the other part times part. So 8x equals 24. We'll divide by 8. X equals 3. And that's what it wanted us to find. The next one wants us to find AC, so we have to find the whole thing. But first we have to do our part times part, so we have one extra step here. So those two parts, 16 times x, or 16x, equals, do the other two parts, 8 times 5. Part times part equals part times part, so 16x equals 40. Divide by 16 to find your x. 40 divided by 16 is 2.5. But then again, it wants us to find AC. So from A to C would be the 16 plus the 2.5, which we just found would be 18.5. Okay, so tangent lines, again, we've talked about a couple rules so far. You'll have to remember they're equal if they come from the same point. If you have two chords intersecting inside the circle, part times part equals part times part. And the last rule we're going to talk about today is if you have either a tangent and a secant, or two secants intersecting outside of the circle, then this is the rule. Outside times whole equals outside times whole. All right, so let's take a look. Let's look at this side. The outside of RT is 4. The whole of RT is 4 plus 6, which is 10. On the other side, 5 is your outside, so it's outside times the whole thing. Up here we did 4 plus 6, well here we have to do 5 plus x. So 5 times 5 plus x, or x plus 5, it doesn't matter. All right, so it's, again, the outside times the whole equals the outside times the whole thing, okay? So we have 40 equals, let's distribute, 25 plus 5x. Now, there's only one x, so I'm going to keep that here. I'm going to subtract the 25 over. 40 minus 25 is 15, equals 5x, divide by 5, and we get 3 for x, and that's what it wanted us to find. All right, determine JG. So again, outside times whole. So the outside of this is 13. The whole would be z plus 13. So 13 times z plus 13. On the other side, the outside is 9, and the whole is 30 plus 9, or 39. All right, so distribute. So we have 13z plus 169, 13 times 13, equals 9 times 39, 351. Just a short equation to solve. We'll subtract the 169. So 13z equals 182. And then divide by 13. So z is equal to 14. But again, go up here. It wants you to find jg. So from j to h, z is 14, plus the outside is 13. 14 plus 13 is 27. Okay, just a couple more to work on. So determine df. Again, I want, or ef will call, or is y. Sorry, that's already there for you. So again, it doesn't matter if it's two secants or a tangent and a secant. Outside times the whole. So the outside is 7 times the whole, y plus 7. The outside, now this one's a little different. This is the outside, but it's also the whole thing. That's the outside and the whole. So 7y plus 49 equals 100. We'll subtract 49 from both sides. 7y equals 51. Divide by 7. Okay, we get a nasty little decimal, so we'll leave it. If we hit math enter, it'll stay 51 over 7. So if we want to now figure out df, I'm going to take that 51 over 7 plus the 7, put it in your calculator, 100 over 7, which is also equal to, if you just divide, 14.28, so 14.3. All right, normally those will work out okay for you though. Okay, so there's a lot going on this next one. We're going to start inside the circle. So if we kind of ignore the outside and just look, we have part times part, right? So, because we have two variables going on here, and then I have part times part. So inside the circle, 4 times x equals the other part times part, 3.2 times 10. So 4x equals 32. Divide by 4, and x is going to be 8. So I'm going to replace that right here. Now to find y, since that's outside, we're going to do outside times whole. So we're going to switch gears now. So the outside of this is 6 times the whole. Well, it's 4 plus 8 plus 6, which we just found, 18. On the other side, the outside is y and the whole is y, so y times y. So if we just do 6 times 18, we get 108 equals outside times whole on the other side, y squared. Then we can just take the square root. And we'll just go to the nearest tenth. 10.4. It was 10.39, but we'll round it to 10.4. That's about as complicated as you might see, but most of the time it's just going to be one thing to remember. So don't forget your 3 rules. If it's 2 tangent lines, they're equal to each other. If they're 2 chords that cross inside, it's part times part equals part times part. And if it's 2 secants or a tangent and a secant, it's outside times whole equals outside times whole. All right, one last question. It tells you OA is a radius and tangent CI. I told you this at the beginning. A tangent line and a radius form a 90-degree angle. So what we're looking at here is a right triangle. So it says if AC is 20 and OA is 7, determine OC. Okay, well, you have a right triangle. OC is your hypotenuse. So it's a squared plus b squared equals c squared. So 7 squared plus 20 squared equals c squared. So we have 449 equals c squared. Take the square root. It says to the nearest centimeters, so we get 21.1, which would be 21. So OC equals 21. All right, so that's it. Your homework is going to be the practice on page 5 and 6, and hopefully by tomorrow we'll have the smartboard back so we can go over that together. Have a good day.